Hello, students and parents. I'm going to explain some of the questions you did in your DBE book. I want you to open up your DBE book while I explain this so that you can follow me. I'm on page 84. I've sent the answer to the first question, number 1, which says, what do we call numbers that are not prime numbers? And those are composite numbers. Okay, so I gave that answer, but I want to focus on the second question. It says here, give the prime factors using prime factor trees. Okay, I'm going to explain that. Before I continue, I would just like to give you an opportunity to make sure that you've opened up your DBE book on page 84. So you can pause and get ready, and then I can continue when you press play again. Right, so I'm assuming that you pressed play, so I'm going to continue now. Right, so if you look at page 84 at the bottom, it says break the following numbers up into smallest prime factors. We will use prime factor trees to demonstrate this. This is a very easy method to understand. Okay, so I'm going to use 12, the example. Just go through that with you quickly, and then we can go on with the questions you did. Okay. So this is called the factor tree method. So what it means is you are breaking up the number, and it's like branches of a tree. So it splits up like that. Okay. So you need to think of two numbers, two factors that multiplies with one another that equals 12. So you can think of 2 times 6 or 3 times 4. If you use 1 and 12, it's like starting from the top again, because you still need to break up 12. So it's not going to help if you say 1 times 12. Rather use the other factors. Okay, so let's say 2 times 6. Okay, now the question says break up the following numbers into its smallest prime factors. So that is referring to prime numbers. So if I look at 2, is 2 a prime number or not? And remember, if you can't remember what prime numbers are, go back to the lesson where I explained it to you. Okay, so 2 is a prime number because it only has two factors, 1 and itself. If you look at 6, 6 is not a prime number. It is a composite number. Because it has more than two factors. So we can break up 6 again. Okay, so think of numbers that multiply with one another that equals 6. And I immediately think of 2 times 3. Okay, then I ask myself again just to check, is 2 a prime number and is 3 a prime number? Yes, they are. Okay, now you will see the question talk about prime factors. Now, these numbers are prime numbers, but when they multiply with one another, they become prime factors. Okay, because they are factors, numbers which multiply with one another that equals the number at the top. Okay, so what I want you to do is circle them and then test whether your answer is correct. So you will say 2 times 2 times 3. 2 times 2 equals 4, times 3 equals 12. And now you can see that you work correctly because it's the same as the number that you started with. So you can see it's breaking up those numbers. It looks like a tree that you have here in front of you, and that's why we call it the factor tree method. Now we're going to use this to get to the answers of the questions you did there. So go to page 85 now, and I'm going to look at number 2A. And I'm going to do number 2C also. I'm not going to do all the questions you did, otherwise it's going to take long to make the video, and that uses a lot of data. Okay, so we're going to start with 18. So split up 18. What times what equals 18? Again, don't think of 1 times 18 because it's like starting from the top again. You need to break up 18 still. So think of 2 times 9, or you can think of 3 times 6. Okay, so look at the two numbers and ask yourself, is 2 a prime number or not? Yes, it is. Is 9 a prime number? No, it's a composite number. So I can break it up again into 3 times 3. Okay, now we know both those numbers, 3 and 3, they are prime numbers, so I can't break it up anymore. So now I'm going to take the 2 and the 3 and the 3, just test whether I work correctly. 2 times 3 times 3. 2 times 3 is 6 times 3 is 18, so I worked correctly. Okay, then I go to C. So this is 30. I can break up 30 with 5 times 6. 5 is a prime number, so I can't break it up, but I can break up 6 into 2 times 3. So now you're going to say 5 times 2 times 3. So 5 times 2 times 3. 5 times 2 is 10, times 3 is 30. So that's how you got your prime factors, the 5, 2, and the 3 in this question. Now, the second method that I taught you about was using factors to multiply. And the question you had to do for me regarding that was on page 85, number 3. Again, I'm just going to look at one of them that you did for me. So we're going to look at 512 times 52. So according to this method, I must take the second number and I must break it up into its factors. So you must think of numbers multiplying with one another that equals 52. But you can go list the factors of 52. Okay? So the factors of 52 would be 1 times 52 itself. 2 divides into 52 because it's an even number. So 2 times 26 is 52. And 4 times 13 is another example of factor pairs, 4 and 13, that multiplies with one another, and that equals 52. Okay, so now instead of saying times 52, I'm going to choose 2 and 26. Okay, so I'm going to say times 2 times 26. So this is in the place of multiplying with 52. It's the same value that you will get, or you reach the same answer. But we are using the factors so that we can multiply easily. Okay, so then what I see here is this is a prime number and that is a composite number, which means I can break this up into prime numbers again, like we did with the factor 3 method. Okay, so if I write that here at the top and you break it up, you can say it's 2 times 13. Okay, so 2 times 13, I can say instead of multiplying with 26, and that is what I've done here. So you see the times 2 times 13 equals the 26 up there. Okay, so I just can indicate with those, like the factor 3, that is where it comes from. So 512 will multiply with 2, again with 2, and then with 13. So I'm using brackets just to keep up with what I'm writing here. So I'm going to multiply with 2 first. So 512 times 2, and then leaving the others outside of the brackets because they are going to be done later. So 512 times 2 equals 1024. Then I'm going to multiply with the second 2, okay, and then multiply with the 13. So 1024 times 2 equals 2048. And then I must multiply with a 13, and that equals 26,624. And then you can check this with your calculator to see whether you worked correctly. Okay, so what is important that we know what the meaning is of factors, identify the factors of the second number, and then in the place of the times 52, you write the factors that multiply with one another that equals 52, and then you multiply step by step until you reach your answer. Okay, now then I ask you to do in the second lesson, in the lesson after the factors, I talked about the vertical column method, and then I ask you to use the same question, the 512 times 52, and use the vertical column method on that. Okay, and in the end we're going to compare the two with each other. So if you remember the method of vertical column method, you look at what are you multiplying here. You've got a 3-digit number times a 2-digit number, which means if I have a 2-digit number that I'm multiplying with, I'm going to have 2 sets of answers. So the first one will be the units, and the second set of answers will be the tens. Okay, and now we're going to start multiplying with the 2. So 2 times 2 is 4. 1 times 2 is 2, and 5 times 2 is 10. When I'm going to multiply with the tens, remember this is actually 50. I put the 0 of the 50 here, and then I multiply with the digit 5. 2 times 5 is 10. Okay, the 1 goes over that 10. 1 times 5 is 5 plus 1 is 6, and 5 times 5 is 25. And now you're going to add this together. So this is 4, that is 2, this is 6, that is 5, and 1 makes 6 again, and then 2. So 26,624. Go back to the method of the factors, and you can compare them. So you can see the same numbers you are multiplying with, just different methods, but you get to the same answer. Okay. Right, and then lastly, I want to go to page 91. You also have to do a vertical column method there. I'm going to look at number 3C. So take your book and page 2 to page 91. Number 3C goes like this. It's 3,265 times 207. Okay, now we have a 4-digit number multiplying with a 3-digit number. So the 3-digit number tells us that we're going to have answers for units, tens, and hundreds. Units, tens, and hundreds. Okay. Right, so let's multiply the units first. So 5 times 7 is 35. 6 times 7 is 42, plus the 3 is 45. 2 times 7 is 14, plus the 4 is 18. 3 times 7 is 21, plus the 1 is 22. And now we go to the next set of answers, the 10. So I'm writing the 0 there. And then you can see you're going to multiply each digit with the 0 because there are no 10. So your answer will be 0 for each one of them. Okay, 5 times 0 is 0, 6 times 0 is 0, 2 times 0 is 0, and 3 times 0 is 0. Now you go to multiplying with 100, so you're going to have 2 zeros for your hundreds. That's the placeholders. So 2 times 5 is 10. Okay, so I'm just putting the 1 above the 6. 6 times 2 is 12, plus that 1 is 13. 2 times 2 is 4, plus that 1 is 5. And then 3 times 2 is 6. And then you add all of them together. So this will be 5, 5, 8, 2 and 3 makes 5, 2 and 5 makes 7, and then you've got 6. Okay, and then go test your answer with your calculator again, if you haven't done that yet. Right, so we reached the end of all the answers. So next time I'll show you the answers of when you calculate using the distributive property of multiplication.